So, as we said before, we have to use Kirchhoff's loop rule. And Kirchhoff's loop rule is just saying that the total voltage drops in a loop have to add up to 0. We're also going to use the junction rule, which says that anytime you have a junction, the current flowing in has to equal the current flowing out. So I've already drawn some labels on this diagram. These will not necessarily be given to you on the exam, and on the next question, they're not there. I'm just including these because we're going to do this problem together. And I think it makes more sense for us to have the same assumptions when we give this a shot. So why is this a tricky problem? Well, there's 2 batteries. One of them is 20 volts, one of them is 10 volts, and we have rules for capacitors. We have rules for resistors. Later on in the course, you're going to get rules for inductors, but we don't have rules for batteries. And there are some rules, but we definitely don't have rules when they're set up like this. So we aren't able to fall back on the usual formulas. What we have to do instead is use Kirchhoff's rules from scratch. Before we can use the loop rule, we have to define the loops. So I'm defining loop 1 to be this clockwise loop here, and loop 2 to be this clockwise loop here. So before we can use the loop rule, we have to define the loops. In the same ways, before we use the current rule, we have to define the currents. And if you ask me, well, what direction is the current going to flow? Quite frankly, I have no idea. Why? Because there's no easy way of just looking at this and knowing. You have to actually just do the math to find out. And that's what we're going to do here. But before we can use the junction rule, we have to guess. So what I'm going to guess here is that the current is flowing this way. We'll call this I total. And if the current's flowing this way, then I'm just going to say, well, let's say it's going to the right here and it's going down I2, and we'll say the current's going here. This would be I total again, because the 2 currents come back together. And again, I have no idea if I'm right or wrong with this. So what's going to happen is when we get to the end of the problem, it might happen that our current has a negative number. And if we get a negative number, all that means is we just guessed wrong at the start. So if I find that I2 is -2 amperes, it just means the current is actually going up the page, not down the page. So now that we've taken a guess at the currents and we've defined our loops, now we can actually use Kirchhoff's rules. I'm going to start with the junction rule, just because it's the most straightforward equation to apply. Let's look at the junction up here, right in this spot. So using the junction rule, so I'm trying to keep my head on the camera while I write here. Okay. Well, the I total has to equal I1 plus I2. There's nothing more to it. That's just saying that all the current that goes in has to equal all the current that's coming out. Nothing left to it. That's really all there is to it. The loop rule is where we get some bigger equations. So I'm going to call this loop 1 and loop 2 based on the numbers that I've drawn here. So loop 1. Now we've said that for our problem, we're going to define a clockwise loop. If you want to do counterclockwise, it's fine. That will also work out the exact same way. But what we have to just do now is follow the entire loop and include an element in the include a term in the equation for each element that we see. So let's start with the battery. The large end of the battery is where the positive current is coming out from. So our loop is going this way. So we're following the positive charge out of the battery. So it starts with plus 20 volts. Now we're going through this resistor. And again, right now we're still following the current. We're going in the same direction as the current that we guessed. So that's going to be a 200 ohm drop. So it's minus 200 ohms times I total. Just to remind you, the loop rule is all about voltage drops. That's why everything we do here is voltages. So I'm using the Ohm's law here, V equals IR. What's current? Well, I don't know yet. I'm just calling it I total. R is 200 ohms. So that's the voltage drop here. Now we're going to keep going around the loop, keep going around the loop. There's no elements up here, keep going down. Now we have a 100 ohm drop. And here we're still going in the same direction as the current that we guessed. So then we get minus 100 ohms. Now here we're going to put I2 because we've defined this part of the current to be I2. Now this part's interesting. Now we're going to come into this battery, but we're actually going backwards through the battery. We're actually going into the positive side. Like here I said, we're following the positive charge out. Now what we're actually doing is we're going against the preferred direction of the battery. So if we go through the battery backwards, it's actually a potential drop, not a potential gain. And so I'm going to put minus 10 volts. Then we finish going around the loop and we come back to where we started. So I have 4 terms in this equation. Of course, we can simplify these. So this is 20 minus 10. So we can say 10 volts minus 200 I total minus 100 I2 equals 0. So that's our equation from loop 1. Now we're going to do loop 2. Let me just zoom out a bit so that we can still see the loop. So one person asked, how do we know we're going through the 10-volt battery backwards? The reason why we know we're going through the 10-volt battery backwards is just from the way that the battery is drawn. Anytime you have a battery in a circuit, whether it looks like this or it's like a larger one, the large side is where the positive charge is coming out from. So current is defined as going out from the big side. In this case, we are going down, and we've said that we basically, because we've guessed that I2 is going downwards, we're guessing that this battery is actually being used the wrong way. Short answer to your question, you have to just pay attention to which side. On this side, we're going in the negative side, out the positive side, but that's how a battery is supposed to be used. So it's plus 20 volts. Okay, so that was, again, just clarifying why we had negative 10 volts here. For loop 2, I'm actually going to start the loop over here just to do the easier part first. So we've guessed that the current is going down here, and that's the same direction as our loop. So this is going to start with a negative 200 ohm. Now what's the current here? The current here, we called it I1. So now we're going to keep going around the loop, keep going around the loop. There's nothing going on here. Now we're going up. Now we're going through the battery the correct way. Or the other way to think about this is we're still guessing. I2 is still going the wrong way through the battery. That's our guess. But it's our loop right now, because we have a clockwise loop. We have a loop that's actually going the opposite direction. So even though we're guessing that this battery is being used the wrong way, our loop is currently going in the opposite direction of our guess for I2. So in this case, we actually get positive 10 volts. So the takeaway here is that the signs that you use when you use Kirchhoff's loop rule, it depends on how you choose to point your loop. As long as you are internally consistent with all of the choices that you make, you will still get to the same right answer. So there's actually probably like 4 or 5 different ways to change the signs on this problem. But this is just how we stay consistent with our own conventions. Let's just finish the loop. So now we've done the 200 ohm resistor. We've done the 200 ohm resistor. We've done the 10 volt battery. Sorry, speaking of batteries, I'm just putting the pen in and out of my battery here. Now we're going through the 100 ohm resistor. So we've guessed that the current is supposed to go down here, but our loop is going up through this part of the circuit. In the earlier part of the question, for this resistor, we had minus 100 ohms I2. But because our loop is going the opposite direction right now, we're actually going to do plus 100 ohms I2. There's only 3 elements in this circuit, 1, 2, 3. So this is going to be the end of this equation. So what's the most important takeaway from this problem? I mean, not that we're done yet, but this is the hard part. This is the physics. The rest of this question now is just math. We defined our 2 loops in such a way, if I just draw a simplified version of the circuit here, we defined one loop that goes like this and another loop that goes like this. They're both clockwise, but on the left loop, we're going down through the middle branch. On the right loop, we're going up through the middle branch. So because the 2 loops that we defined are opposite directions, because the 2 loops that we've defined have opposite directions for the one branch, we have to have opposite signs for these 2 elements. So we had, in the first loop, we had minus 100 ohms, I2, minus 10 volts. In the second loop, we had plus 10 volts, plus 100 ohms, I2. If you ever define your loops in such a way that there's a different direction for one of the branches, this is always going to happen. And now you might say, well, that's really annoying. Why didn't we just define our second loop to be the other way, right? And you could absolutely do that if you wanted to. So let's say, okay, like that was annoying. Let's change loop 2, let's make it counterclockwise instead. If you wanted to do that, it would change all 3 of the signs. It would be like if you take this entire equation and multiply the left and right side by -1. So you would get plus, minus, minus, which obviously doesn't actually change anything because it still equals 0. You can multiply and divide these equations by whatever you want. So there's some questions there about the negatives and the pluses. I hope that explanation helped. So I'm just going to dismiss those. They came in while I was already answering it. And we're going to do another question like this next, by the way. So we'll see another example of this in motion. Okay, so we've set up our 3 loop rule equations. Again, just whatever currents you define at the start and whatever loops you define at the start, as long as you're consistent with those, you'll get to the right answer. That's the most important part. So let's just put some numbers on these equations because now it's actually a math thing. So let's call it equation 1, equation 2, equation 3. This is the boring part. Now now we have to just solve it, do the math basically. So let me just show you one way of doing it. Put equation 1 in 2, do a substitution. So you get 10 volts minus 200. And we're going to replace I total with I1 plus I2. So we're replacing this with the first equation, minus 100 I2. That's equal to 0. This can be simplified a bit. So this is 0 equals 10 volts minus 200 I1 minus 200 I2 minus 100 I2. So it's total of minus 300 I2. Now this equation looks kind of like equation 3, right? So just to put 3 here, it's 10 volts minus 200 I1 plus 100 I2. So now that we have these 2 equations, we're just going to subtract these 2 equations. What you're actually going to find here, so if you do this starred equation minus equation 3, you're actually going to end up with 0 equals 0 plus 0 minus 400 I2. What this means is that I2 is actually equal to 0. That's the only possible solution to that equation. And so let's stop for a second and think, hold on, what does that mean? Like, did we make a mistake? Well, no, it just turns out in this question, we were so concerned about guessing the signs and the directions of things. Turns out just by the voltages that we happen to pick and the resistances that we happen to pick, there's actually no current at all flowing through the middle branch. So it's an interesting case of what can happen in a Kirchhoff's law problem. If we had found this number to be negative, it would have meant that there's a current flowing upward. If we had found this number to be some other positive number, it means that we guessed right, that it's going downward. So what you could do, by the way, in this question is you can just do this exact same question again, just change some of the numbers if you want. And as long as you don't multiply them, don't double all of them or cut them all in half, change them into weird different numbers. The reason why we got I2 here is just because the numbers happen to give us I2 equals 0.